workshop called Montane Wet Forests. And my advisors were Dr. Peyton Minton and his grad student Mike Long, and also Dr. Christian Giordino from IFIT. The main thing that we focus on is the impacts of pigs. Feral pigs in native forests, they like to grub, they search for insects, worms, and roots. They damage plant life, especially like understory plants, things that have a lot of meat to it, like hapu'u, ferns. They like to wallow, which makes it hard for water to percolate through the soil, hard to go down. So it kind of causes ponding and massive wallows. And they also damage roots, which help the makeup of soil or respiration. What is soil CO2 efflux? So CO2 efflux is a basic way of saying how soil breathes or respires. Soil doesn't respire itself. The makeup of stuff in soil respires, so like the roots, the organisms in the roots and the soil, so like the worms and the insects. It is also affected by the environmental and biological factors, so like soil temperature, the atmosphere above, the moisture, canopy levels, how that is shaded, all that kind of good stuff. So the first thing that we have to do is insert collars. These collars are 10 by 15 centimeters, and it's basically just PVC tube. People also use metal ones, but that would be kind of heavy to hike all the way in the forest. So this is our basic map out of how we insert the collars. We have 12 collars per site, and there's 4 plots per site. So one collar each cardinal point, north, south, east, west, and 2 collars in between each cardinal point. The way we look at the soil efflux is with this machine. It's called a Lycor. We use Lycor 8100, and it's a chamber that circulates and collects and records all of the levels of CO2 that effluxes, respires out of the ground. So this is the chamber. It's pretty cool because you turn it on with the box and it basically like rises. But the only bad thing to it is you gotta wait. So like we go to each plot and you gotta measure each collar. And this thing can take, if it's bad, like really bad, takes bad measurements, it can take like up to 12 minutes per collar. So we have a lot of long days out there. This is our location site. We focused, or my project mostly focused on the Pu and Ola'a. Pu is right here. I don't know if you can see them up here, but right here, around here is the end of White Road in Volcano. So you go all the way there. You gotta hike along the fence over here to go here, and you go this way to Ola'a. Ola'a is how we say pig-free zone. No, yeah, pig-free. No.
Because they're up.
And then Pu'in is 19.5 years without pigs. So we're looking at plots. Each sets of plots are paired with fenced units and unfenced units to see the differences how pigs both affect the native forest, and when you remove them, see how they affect the forest then. Our two units that I focus on are both managed by Hawai'i Volcanoes National Park. The altitude ranges from 4,250 and 3,800 feet. Yeah, these are big areas. We don't know how big Ola is because it's an unfenced unit. The area of Pu is 240 acres and it was fenced in 1989. And the end of the major impact, so after they fenced it, they seen the end of the pig damage around 1992. So that's why they officially say time since 19.5 years, not since 1989. So my three major questions to ask is, how does pig removal affect CO2 efflux? How does pig removal affect soil temp? And how does the pig removal affect soil, water, or volumetric water content? And this chart shows that after removing the pigs, CO2 levels rose. I think this is because being that you remove the pigs, there's nothing to cause the soil to not efflux. And the pigs present, when they're like wallowing and digging up everything, it kind of makes it difficult for the soil to respire. In the volumetric water content, we found that there was actually less water in pig-free zones than in pig-present. The soil temperature compared to the soil respiration, there was not really a big change in soil temperature. I think this is because basically being just around the atmosphere and how cold it is up in volcano, it doesn't really differ. And my last graph shows the basal area of native species in both pig present and pig free. We found that in the pig present, there's a lot of Ohida, so major dominating species, rather than in without pigs, there's more Koba'u and Olapa. That was